Hello everyone, welcome to Gangs of PCM. This is Priyanshu and together we are going to solve all your physics related worries. Today we are going to discuss a question from JEE Mains exam which was held in January of 2020. This question is from chapter rotation, and to solve this question we need to know the concepts of conservation of energy, free body diagram, equations of motion and torque on the rigid body. This question can be solved using two methods. One is force method and another is energy method. So we are going to use both these methods to solve this question. Okay, so let's first look at the force method. Okay, in this force method we will be using FBD, equations of motion, torque and all such things. So let us dive into the question. We have a question where this is our pulley and the pulley is attached to a string, and with that string is attached to a mass m. Let us say at time t equals to 0, the velocity is 0, the system is stationary, this is at t equals to 0. When the system is released from its rest position, after a certain amount of time, it has fallen by height h. Now let us assume that velocity at this instant, at any time t, the velocity of the mass is m. Let's say its acceleration is a in downward direction. Okay. Now, one assumption we are taking, assumption is that string is not slipping on the pulley. Here pulley is a disc. Okay, uniform disc. So string is not slipping. The string is not slipping. That means what? That means whatever is the acceleration of the string, this would be tangential acceleration of pulley, and whatever is the velocity of the string, that would be the velocity of pulley, or we can say better, tangential velocity of the pulley. Okay, and similarly, since mass is connected to the pulley, so acceleration and the velocity of the string would be same as acceleration and velocity of the mass. They would be same. Okay, so now we know this. So if the acceleration of string is a in downward direction, the acceleration of pulley would also be a or tangential acceleration of pulley would also be a in the downward direction. So now let's draw the FBD of pulley. Now what do we have over here? We have a pulley which is fixed at its center and it is free to rotate. It is pulled by a string with tension T. The tangential acceleration is at, the mass is m, and the radius is r. Okay, so in this case what we can say, the torque is provided by tension in the string T. Why is that? Because again the string is not slipping on the pulley, so we can say torque is equals to, since we know that torque is equals to r cross f. Here f is the tension, so we can magnitude of torque would be how much? Rf sine 90, because the radius and tension have 90-degree angle with each other. Okay, so from here we get tension as r into t. Also, since torque is equals to I alpha, where I is moment of inertia of the rigid body and alpha is the angular acceleration, so we can say I alpha is equals to RT. Okay, so from here we get tension as I for disk about its center of mass, moment of inertia is mr square by 2. So we'll put the value mr square by 2 t into alpha, mr square by 2 into alpha by r. Okay, now we know that tangential acceleration is equals to alpha r. Tangential acceleration is equals to alpha r. So alpha can be written as at by r, or here a by r. So we'll have tension in the string equal to mr square by 2 into a square by, sorry, not a square, a by r square. So r square will get cancelled. From here we get tension in the string is ma by 2. This is an important result. We'll use it later. Now, if we draw FBD of mass m, FBD of mass m, let's see what would happen. FBD of mass m. So we have this mass m. It is pulled up by the tension in the string, down by the gravitational force mg, and it is going down with an acceleration a. Using second law of motion, we know that what? Mg minus t, net force in downward direction, would be equals to mass into acceleration in downward direction. So we know the value of tension as ma by 2 is equals to ma. Send this value over here, so we get from here mg is equals to 3 ma by 2. Mass and mass will get cancelled, so we get value of acceleration as 2g by 3. Okay, we get the value of acceleration as 2g by 3. Now let's see what's happening over here. Now we have a mass m which is at t equals to 0 has velocity 0. At t equals to 0, at any time t, it has fallen by height h, and the velocity, let us assume, is v. Now using third equation of motion, what we know, v square is equals to u square plus 2as. The acceleration is a in downward direction. The v square we don't know, u square is 0. 2 into acceleration is 2g by 3. Just now we figured it out, and s is equals to h. It is fallen by displacement of h. From here we get v square as 4g h by 3, or we can say velocity as root of 4g h by 3. Now again, this is the velocity of the string, velocity of string. So this would be same as tangential velocity of pulley. So if we have this as a pulley, the tangential velocity is equals to v is equals to root 4g h by 3. Okay. Now at this instant, if it is omega, it is rotating by angular velocity of omega, we know the relationship that vt is equals to omega r. R is the radius. So we get value of omega as 1 by r root of 4gh by 3. This is our answer. So this is the force method. Now let's solve the question using energy method. Energy method. This is much simpler method. Okay. So in this case, we'll talk about the energy of the entire system. Again, we'll look at the pulley. So this is our wall, rigid wall. And from here, pulley is fixed at this particular position. We have mass m. This is the position at t equals to 0. T equals to 0. Velocity is, initial velocity is 0. We'll consider this line, center of mass of this line, or this height of the center of mass, as a reference point. Center of mass of the pulley, reference point. What does it mean? That means potential energy at this line is 0. So whatever the potential energy will measure from this point. So potential energy above this point would be positive, and potential energy below this point would be negative. Okay. So now what is happening? This is falling down. This mass is falling down. This mass is falling down till height h. Okay. Let's say the initial height is h1 below the reference line, and it is further fallen down with the height h. At this instant, its velocity is v. This is at some time t. Okay. So that means what? Let us say if this is the situation 1 or condition 1, and this is situation or condition 2, then since no external, or no, not an external, since no non-conservative force, since no non-conservative forces are acting on the system, there is no friction anywhere, then therefore you can say what? Mechanical energy at condition 1 would be same as mechanical energy of the system at condition 2. Okay, so we'll solve this. So mechanical energy of system at 1 would be what? Mechanical potential energy of pulley plus potential energy of mass m plus kinetic energy of pulley plus kinetic energy of mass m. This is entire happening at case 1. Okay, So from here we get mechanical energy 1 would be potential energy of pulley 0. This is at the reference line. This is down by height h1. So we'll have minus mgh1. Kinetic energy pulley 0 because the entire system is at rest. So kinetic energy of pulley and kinetic energy of mass both would be 0. Okay. So from here we get mechanical energy at position 1 as mgh1. Now what about potential energy at, or sorry, not potential energy, mechanical energy at position 2 or case 2. So we'll have again potential energy of pulley plus potential energy of mass m plus kinetic energy of pulley plus kinetic energy of mass m. This is your system, this is your case 2. Let's figure it out. So potential energy of pulley again 0 plus minus mg h plus h1. This is the height. Now it has fallen by h1 extra h1 height. So the total potential energy of the mass would be this much plus kinetic energy half mv m. Oh, sorry. So let's say this is kinetic energy of mass m. So this would be half mv square plus half I omega square. This is kinetic energy of the pulley. At this particular instant, we'll say that it is rotating by angular velocity omega. It is at time t. Okay. So mechanical energy in case 2 will have minus mg h plus h1 plus half m. Now v square can be written as omega square r square. Same, this is the tangential, this velocity would be the velocity of the string. So this would be same as the velocity of, or tangential velocity of the pulley, which is equals to omega r plus half. I is what? mr square by 2 into omega square. See, from here then we can say mg h plus h1 plus, if we take mr square as common, mr square omega square as common, so we'll have half plus 1 by 4. So this would give you 3 by 4 mr square omega square. Now since mechanical energy at 1 and mechanical energy at 2, they are equal, then what does it means? Since mechanical energy at 1 is equal to mechanical energy at 2, what does it mean? Minus mgh1 is equals to minus mgh minus mgh1 plus 3 by 4 mr square omega square. mgh1 mgh1 get cancelled, so we'll have mgh is equals to 3 by 4 mr square omega square. So from here we get omega square as 4 by 3 gh by r square. This gives us omega as 1 by r 4gh by 3, root of 4gh by 3. This is our answer. Now if you look at the options, our option 4th is the correct one. So correct answer is option D. Thank you everyone for coming back again. Okay, I hope everyone is able to learn something. That's it for this video. Thank you. Bye bye.